Okay. So I'm going to do number 3. I'm going to do at least part A for number 3 to show you how to do it when it's perpendicular to the y-axis. That's going to force you to do it. And I have seen this on the AP test as well. It's going to force you to do it as a dy problem. Okay? So one of the things that we have not discussed yet is how to find the area when we do our cross sections that are perpendicular to the y-axis. So it's like we're drawing rectangles that are now going this way instead of straight up and down. So we know it has to be set up as a dy. It's going to say perpendicular to the y-axis. So there's no guessing in there. Perpendicular to the y-axis means dy. But the formula for area becomes a little bit different. Okay? We know that when we do the volume with a dx, we always do top minus bottom. So when we do the volume with a dy, we're going to be using a lot right minus left. Okay? So just like it was when we did dx, when we did top curve minus bottom curve, when we do dy, it's going to be right curve minus left curve. And the way we integrate it is we draw our little shapes starting at the very bottom. So we integrate from the bottom of our area all the way up to the top of our area. And for us, the biggest squares will be happening here at the bottom because that's where we have the most distance between our two sides of our area. Okay. And we'll have our smallest squares at the very top. Okay. So we have all these different size squares popping out of this area. Okay. But now they're going this way. They're slicing them this way. Okay. So that's how you set up an area when you have to do it as a dy. We almost gave one of those as extra credit on your last area quiz, but you had so many area problems to do and it already took you so long, we decided not to do that one. Okay. Yes. Oh. Okay. So now I'm going to go ahead and do the volume of this graph right here. I'm sorry, the volume of this three-dimensional object with squares popping out. Do you guys know what this symbol means?
Perpendicular.
Perpendicular to the y-axis. Exactly right. Okay. So I'm going to have to integrate my s squared because that's the area formula for a square, and it's always that same formula. Okay. But now when I plug in for my s, I have to plug in y's. I'm not allowed to plug in any more x's. Let me see if I can find the limits of integration first for this area. So I kind of took this shape right here, this area, and I made it bigger over here so I could actually draw on it. Right? So I just blew it up. Okay. This was too small for me to write on, so I just blew it up. That's why I color-coded it for you. Okay, so I'm now going to go ahead and find the bottom of that area, and then all the way up to the top. I already know where the bottom is. It's at y equals 0. Okay, that's the bottom of my area, so I know that this is going to be a 0 in here. The top of my area is going to occur where those two graphs intersect. So if I want to find out the top of that area, I'm going to set those two graphs equal to each other. I'm going to solve for y, not for x, but for y. Okay? So I set y equal to x cubed, and x is 1. So y is going to equal 1 cubed. Oops. Blue. So y equals x cubed, and x is 1. So y equals 1 cubed, or y equals 1. That's where those two are going to meet. Okay? So that's at a height of 1. So I know I'm going to integrate from 0 to 1 on the y-axis, from the bottom of my area to the top of my area. Now I have to find out what one of those sides of my squares is going to be. And to find that out, it's just going to be right curve minus left curve. So this will be right curve minus left curve. So just like we did when we did our dx, and we always had to put in a top minus bottom, we'll be doing a right minus left when we do a dy. And so the curve on the right is the curve x equals 1. So we can put, I don't know why I put dy, I'm sorry, that's supposed to be v. So the curve on the right is x equals 1. Notice how that is solved for x. The curve on the left is y equals x cubed. But I can't plug in an x cubed because I have a dy. So what do I have to do to this equation before I can plug anything in? You have to solve it for x. now I could plug that function in as the cube root of y rather than x cubed. Okay? So I'm going to plug that in, and it's going to get plugged in as the cube root of y. And that whole thing has to get squared. And that's it. That's my setup right there. That's going to give me the volume of that shape. Okay. So anything, when you have to do a dy, anything that is not solved for x, you have to solve it for x, because it's the y part that you want to plug in now, not the x part. And it's okay that you didn't know the answer to that, because we hadn't done one like this. Okay. But that's what you have to do. If they give you things that are solved for y, when you're doing a dy, you don't want them solved for y. I know it's kind of weird. Okay? When you do a dx, you want them solved for y. When you do a dy, you want your equation solved for x. So, back to area, the only time that I would actually do it as a dy is when they give me the functions that are already solved for x. That'd be the only time that I ever do an area as a dy. Right? Sometimes you can look at an area and say, you know what, it might be easier to take the area of it going from bottom to top rather than from left to right. One of those areas that I could think about, maybe a shape like this. I can't think of one right now. No, that's not going to be a good example. That would require 2 if you go top to bottom, but it would still require 2 going from right to left. But I know there are some examples out there, I can't think of any right now, where it'd be easier to do it as a dy, because of the way the picture looks, than a dx. Okay? Sometimes a dx will require 2 integrals, and a dy will only require 1. But you got to make sure that you plug in y's. So every function now has to be solved for x, the other variable. Now, when I plug this into a calculator, the calculator don't care if you plug in an x or a y. So when I plug it into a calculator, I'm going to replace all those y's with x's, because the calculator doesn't care. Okay? It doesn't know what variable belongs where. Okay, let me have this picture back up here. There we go. How come that's not very bright? Thank you. Thank you. Okay, so I can even store it in. I'm going to store it in as the cube root of x. Okay. The calculator doesn't care if it's x or y. You just need to put a variable in for that calculator, and we always use x. The cube root is under the math button. If you hit math, you get this list of all this. You can also do x to the 1/3. The cube root's number 4. Okay. And you can put in any one if you do that one. For number 5, you can do like 4th roots or 5th roots. Okay. But if you just want a cube root, that's number 4. So I stored it in. I don't think I need to put in the 1. I can just put that in. I think I'm ready. I'm okay with that. If you want, put the entire thing in and square it. That'd probably be the easiest way to go. Okay. So how about this? I will do that. Let me insert a parentheses here. There's the cube root of x. Let me put in the 1 before it. And I'll square that whole thing. That way I can just put this in as a y4. So I have 1 minus the cube root of x, and I squared the whole thing. So now when I put this in my calculator, I just have to put that in as a y4. I put mine in as y4. So I'll quit math 9 from 0 to 1. See, it's much nicer numbers. Much nicer numbers to do it this way. And then that's going to be y4 bars, y bars, number 4, dx, enter.
It's thinking.
It does, it takes a long time to do. 0.099, and that's good, 3 numbers after the decimal. You can also probably call that 0.1. There's nothing wrong with that either, because there's so many 9s after that other one. All right, let's see. Yep, they called it 0.1. For my guys, I didn't print you guys out the answers. Did you print out their solutions for them?
Yes.
Yeah.
So do you want one of my worksheets?
If you guys want to take a picture of it, you guys can. You guys can. I don't usually print out the answers for my kids until after they tried it. This one we found a correction right here. This one is 3.507. Did you find any other corrections? D, this is correct.